so everybody can see it. All right. All right, so I'm going to give a little talk on communicating between Raspberry Pis and Arduinos. Kerry King was here this fall, and so that was one of the things that was lacking on his website. He runs a website on Arduinos. So the slides don't track. Interesting. So why do we want to do this? So my goal here was to communicate, have a program running on the Pi, and have a sketch running on the Arduino, and be able to communicate between them. Arduinos run real-time, have analog inputs. Pis are great for talking to the internet and writing complex code. And so sometimes you want the best of both worlds, but you need a way to talk between them. So first we'll talk a little bit about the hardware. The Pi has two pins, a transmit pin and a receive pin. They break out on pins 8 and 10, and they're connected to a UART. A UART is a universal asynchronous receiver transmitter. It's a piece of hardware that knows how to do serial protocol. The Arduino has two pins. The Uno has two pins, 0 and 1. The ones that you never use in any of your sketches. And they're connected to a UART, and they're used to talk to the host, used to download the program, and to run the serial monitor. So I talked about what a UART is. There's different baud rates, you can do different speeds. We'll talk about that a little bit. So you might think, well, let's just hook them up. We've got our Uno over there, we've got our Pi over here. We want to transmit on one to talk to receive on the other. And it's also very important to hook up the ground so they have a common ground reference for their signals.
Aren't you running a risk with the 5 volts there?
Yeah. If you do that, you blow up your Raspberry Pi pin 10 and all kinds of bad things happen. So no, you don't do that. So what are your options? You can use a 3.3 volt Arduino. The Pro Mini is a 3 volt device. The Arduino Due is a 3.3 device. Kerry King's YourArduino.com sells an Uno clone, has a little switch. You can switch between 3.3 volts or 5 volts for the signal. So that's one option. The other one is you can do some level conversion. So you put some logic in between that takes a 5 volt signal and drops it down to a 3.3 volt signal. And you could run the other way as well, although the Uno, if it sees a 3.3 volt signal on a 5 volt input pin, is just happy with that. That's high enough to be considered a 1. So you don't really need the up voltage conversion.
Isn't that the easiest way to do it and safest way?
It does protect your devices with potentially some cheaper logic in the middle. And I know you like to do that when you've got high school kids playing with Pis and have some protection in the middle. If you're a minimalist, you want to save every penny, and you can get away with that. All right, so my first thing I'm going to show you is I'm going to run the Due here.
Well, in there, back on the page before,
Yeah.
well, things like flow control, hardware or software-based flow control, and says, hey, my buffer's full, please stop, that kind of stuff. Do you need that at all?
We'll get to that.
Okay.
If you run things slow enough, you don't need any flow control. How's that sound? You might not need any flow control. All right, so what I have up here, I got my laptop, I've got a little router, I've got my Raspberry Pi B Plus, so it's not the new quad-core one. And then I have a breakout thing which takes through a ribbon cable, breaks out all the 40 pins off of the Pi. And if you read upside down, it's an Adafruit T-Cobbler Plus. They make one for the old Raspberry Pis that has 26 pins, and they make this one for the newer Pis which have all 40 broken out. This is essentially an Arduino Due. It's actually a DigiSpark Digi-X, which has some other advantages, but you don't need to know. You can ignore the stuff at the top here. So I have ground connected together, and I have TX and RX crossed over. And so here's the sketch that I'm running on the Due. The Due has 4 UARTs. One is for communicating across the USB cable to the host. And then it has 3 others that are called Serial 0, Serial 1, and Serial 2. Serial 1 talks to some Wi-Fi device that's on the board. So I'm going to be using Serial USB, which is an alias same as what you would normally use, just plain serial in a sketch. And so I'm going to fire up serial USB. I'm going to fire up serial 0.USB, which is the one that's attached to pins 0 and 1. Both of them I'm running at 115/200 baud rate, which is the default serial port speed for Debian Linux running on the Pi. So I program my 2 serial ports, and then I look to see if anything's available on port 0, and if it is, I read it out of port 0 and I write it on port USB. And then I look at anything on USB, I read it out of USB, and write it to serial port 0. So it's just a little crossover, not doing much at all. All right. So now the Pi currently is powered off. So there's the serial monitor from the IDE. I've already got that sketch loaded on the Due. And so it's starting to do things on the serial port. That's coming from the serial port on the Pi to the Due. And the Due is echoing all those characters to the USB connection to the laptop.
So you're running the Pi under SSH?
No. No. Am I running Pi on SSH?
I mean,
I'm-
you've got the Pi up and running,
I have the Pi up and running.
and you're running it through your, since you don't have a monitor or a keyboard.
So
you're-
what I've done on my Pi is I run VNC, XVNC, so that I can VNC in
Okay.
to the Pi. I'm currently not doing that, so there's nothing really connected to the Pi other than these 2 wires. It's the serial port.
So you booted the Pi headless, and it's just talking to your Due.
Yep. And so we got all the spew of the boot, the console spew of the boot, and now it is at the login prompt because Debian spawned a terminal on that serial port for you to log into.
Is that by default? Whenever it
That's
boots
by
up,
default. This
it
is the
automatically spits
vanilla.
out to the serial port.
So this isn't really what we want, right? We want to have a program running on the Pi that can talk to the Arduino. But so since I had the echoing, going both directions, I can do this. I should be able to log in. This may not. Okay, so I typed pi into the serial monitor. That got sent to the Arduino. The Arduino saw inputs on serial USB, copied them to serial 0, which goes over to the Raspberry Pi, and now it wants the password.
This is your root password?
As it turns
Well,
out.
in the Pi, it's only one, so.
The default login, the default account on the Pi is named Pi, and the password is Raspberry.
Yeah.
So I logged in, and looks pretty good, but there's some strangeness, right? So it's not quite perfect here. So if I cat, so this text is in a file called /etc/motd, message of the day. And so if I cat it, it's a little bit better, but it still gets messed up a little bit.
And that's just from not having a hardware handshake on the serial? I mean, the Arduino's not keeping up with it?
That's my suspicion. Okay, now this is with a hardware UART, right? It did pretty good for 100 characters or so, but eventually somehow couldn't quite keep up. The Due runs at 84 megahertz, okay, but we're running a bit rate of 1.15 megahertz or something.
Is that the bit right in the lower corner there?
Yeah, doesn't that say you're running at 38.4?
It does, but it's wrong.
Okay.
I think the Arduino's FIFO buffer is only 64 bytes.
That's typical of a UART, or generous for a UART. They're often only 16 bytes.
Oh, so that's not it.
But so the sketch, you saw the sketch, right? There's not a lot going on. There should be, I do some quick math in my head. So you get about 80 instructions per, 80 cycles on the Arduino clock, which means you could do 80 instructions during 1 bit time. If you have to handle an interrupt, it takes 100 cycles to do the prologue and shutdown of an interrupt. So that's over a bit time. So it's not surprising that these rates, we lose a few things. Okay, so what am I supposed to do next? Right, so I'm going to, while I'm talking to the Pi, like my demos directory, and run a little script that sets up for demo B. Right, and so I'm going to turn off the Pi.
All these suspect that loss of character sync is actually noise because the lines aren't differential, you're just straight digital, and even you're going a short distance, you're gonna have, or do you expect that you're
I do not suspect that. I suspect that it's timing.
timing?
It just doesn't have enough cycles to get that much stuff. And And so that's kind of what we saw. In case the demo didn't work, I wanted to have a picture of what it was supposed to look like. I brought my logic analyzer scope. We can look it up if you want later. One of the cool things is it has an interpreter that you can apply to one of the logic signals, and it will interpret it as serials. You configure the baud rate, the number of start bits, stop bits, parity, that kind of stuff. And so here it sees PASSWORD colon something, probably a new line or something. So this is the TX from the pi to the RX of the Arduino. So the pi spit out this string. If you take some cursors and you stick them on one of these little pulses, it'll say, the oscilloscope will tell you what the frequency is. And it's 115.2 megahertz. Kilohertz. So the width of each individual bit here is in kilohertz is the baud rate. And there's also some, you've heard start bits, stop bits. So serial ports are useful. Linux uses them, right? The console spew goes out to the serial port, and it sets up TTY on that serial port for you to log in. So there's a file /boot/command-line.txt. Now this is Raspbian distribution for the Pi. If you use another distribution, everything's the same except it's totally different. The syntax is all different. The names of the ports are all different. And so in flavor it's the same, but in details it's totally different. So what I'm doing is for Raspbian. So if you want to turn off the console spew, okay, you delete that stuff in red. If you want to change it to a slower baud rate, if you want to slow it down to 38400 or something, you could change it to 38400, and then we wouldn't have those character losses. Similarly, in /etc/init tab, there's a line at the bottom which fires up the TTY daemon on the serial port. Again, if you want to change the baud rate, you change 115,200 to a different number. If you want to get rid of it completely, you just comment it out with a pound sign and then reboot. So I think that's what I did for demo B1. So we talked about most people don't have a due rate. And so for my next demo, I'm going to go back to an Uno. So I have to rewire some stuff here. Now the Uno only has one UART, and that's used to communicate across USB to the PC. And it has some connections on those lines, which is why they tell you never, one of the reasons they tell you never to use those pins for your sketches, because they're already hooked up to something. But there's a software solution. So there's a library called Software Serial that does bit banging. Bit banging is using software to manipulate the signals and emulate what the hardware, what a UART would actually do. And it's not nearly as fast as dedicated hardware, especially when running on Uno, which has a clock speed of 16 megahertz instead of 84 megahertz. So instead of 80 instructions per bit time, now you're down to 16 or 15 or... So we're going to slow things down a little bit. Pi is off. To unplug the duvet. Disconnect. I didn't set up already, isn't I? USB cable. So this is the configuration. I'm using the Robo Red, and there's a switch right here, which says 3.3 volts if it's up that way, and 5 volts if it's down this way.
That's from the guy in Vermont, right?
Yes, yourduino.com. All right, now I'm going to run it. It's currently in the 5 volt position. And then I have some logic right here in the middle. And this is a, get the number right. Supposed to be on that slide. It's Adafruit part number 735, and it's a 74 LVC 245. Essentially what it is a buffer. And it's a you can choose the direction, but we only want to go one way. And it's I believe a pair of the Darlington resistor pair. You send the signal in one side, and out comes that signal on the other side. Now the cool thing about this chip is that it allows an input at a higher voltage than the chip is running at.
Why wouldn't I, well, I could use the little level shifter that I can get from SparkFun, right?
Sure, you can use any level shifter you want.
And why would this be better than,
I don't know what that one is, so I'm
Be less expensive.
maybe less
would
expensive.
this one be from the SparkFun one?
That's a raw chip.
This chip is about 50 from
Oh,
Adafruit.
oh, geez, yeah, okay.
Yeah, and I mean, this is a, I think it's a 20-pin chip. It has 8 channels, okay? And so I'm only using 1/8 of the device, and the other 7 channels are all tied to ground. It can't work both ways. You can't do 3 to 5 this way and 5 to 3 that way. You can kind of do either or. And so if I wanted to do both, I need to buy 2 of these 8-channel things. But I'm only protecting the 5-volt Arduino to 3.3 volt Pi direction. And I'm letting the 3.3 volt be used as an input to the Pi. Okay, so I need to hook up. I've already got my grounds together. And I'm going to hook up the transmit. And I'm going to hook up the receive. I have a schematic for how to wire up the level shifter. It's in my backup slides, I wasn't gonna go through it now. It'll be in the slides when we post them on the website.
Regarding the level shifted boards, there's another option too, if you were willing to wait a few weeks. Bluestream.com has one that I buy, it's $2.50 for one that's a board IC ready to go. It's easier if you're trying to use a board and wire it that way, than using an experiment kit. It's the same board that Sparkfun is selling for a fraction of the cost, but you have to wait a week for Verizon, which
I saw on your board you had a 3.3 volt save, and you have that on now?
Right now it's set at 5,
Oh.
because that's what a normal Arduino Uno would be. If I ran it at 3.3, I could skip having the level shift. But I already showed you to do a 3.3. All right, so here's the sketch I'll be running. I need to be uploading that. Let's see if I got it. So we're using software serial. I've chosen to use pins 2 and 3. It's pretty much arbitrary. You can use any ones you want. You don't want to use 0 and 1. I fire up the serial port. It's on the hardware UART going to the PC at 38400. And I fire up the software serial, which go into the Pi at 9600. When I set up the Pi, I changed the baud rates down to 9600. And then again, I'm gonna see if there's bytes on one, send it to the other, see if there's bytes on the other, send it back to me. And it's still compiling. The new IDE is slower than the older IDE.
Hey, Paul, one thing I found with doing software serial was that certain baud rates, there's error because the clocks, the system clock doesn't match up with the peripheral clock. So when you use a hardware serial, and the data sheet will give you error rates, but ironically, the software serial, I think, gets the timing better. So for certain baud rates, I've had better luck.
With software serial?
With software serial. But it's more, the CPU's hung while it's communicating,
Yeah.
But sometimes you don't have a choice in baud rate,
I know what's gonna happen here. I've got the wrong USB port. It's still saying it's COM18, which is what it had for the DigiSpark. And so it's going to sit here and compile for 3 minutes, and then it's going to tell me there's not an Arduino Uno on COM18, and I'm going to have to unplug the USB, plug it back in, find it, and then recompile. It's still compiling.
So long as you set your expectations.
All right, so this is what drives people to use different IDEs. This is
Different operating systems.
A problem uploading to board. Surprise, surprise.
Does anybody know if the software serial writes and or reads turn off interrupts? Do they hold interrupts off while they're doing
The transmit
Yes,
does turn
the
it off while
transmit.
it's sending the entire byte, and you will lose anything.
Well, if you hold it off for, the whole time. That way you
Software
don't,
receive
that way you don't
interrupts.
build, you don't create invalid data.
Yeah, you'll get the right timing for the outbound signal, but you will lose accuracy on the receive interrupts at all. So you can't send and receive at the same time
Right.
necessarily, depending on the baud rate.
Right.
The slower your baud rate, the longer you're actually going to take the interrupt down.
Okay.
And you do need
Also, plugged it in, it would
for
work
that,
better.
on the receive, you can only do certain things because it needs to use interrupt, pin change interrupt.
It does use a pin change interrupt.
Shouldn't have said that out loud, Paul.
Oh, I'm 22, there you
Pin
go.
change on any of those. Don't use your.
Well, we'll take this,
Go to pin change on 40.
okay, go to the schematic here. So A1 and B1 are hooked together, and depending on what level you apply to the direction pin, tells whether it goes that way or this way. The pin, the chip is run at 3.3 volts. And you can't just get any old 74 or something, 245, and use it as a level converter. You have to check the data sheet to see if the input pins are tolerant. Most of them will say the input pins can go from 0 to VCC plus 0.0 something volts. You go a little bit higher than VCC, but not much. This pin, this device is specified, it can go up to 7 volts or something on its input.
Does this have something to make it more desirable than just using a little 2N222 BJT to translate the 5 to 3?
Probably not. If you Google around, you can find the circuit for that. You know, there's a couple of resistors and other things that you have to.
Two resistors will be BJT when you're done.
Okay, so there you go. That's even cheaper than this $1 part from Adafruit that you can get for less than that for DigiKey. Oh, good, done upload.
Another question?
Yes.
Would another direction to go be to get an actual UART chip that might do the level shifting for you and also allow the UNO to use a byte interface to the chip or a multiple bit interface to the chip to bypass any baud rate limitations in the serial port?
That would definitely do. Most of what I want to do when I'm talking between them is really low bandwidth stuff. And so 9600 baud to send 12 characters once every 5 minutes is just fine. But if you really need more communication, look at other alternatives.
I'm just wondering if with more wires I could get the same 15K bandwidth out of a single chip, and maybe it is a $6 chip instead of a $1 chip, but do the job. And it would cost me more wiring, but still be a single chip solution.
Use it more of the ports on the Arduino does real fast.
Yep.
I2C would be good, I2C.
I2C,
400
SPI.
kilos.
What about using the USB serial of the Arduino, to the Raspberry Pi, using that, once you're done with the programming it?
That works too. I'm doing that currently, just hooking up the tube between use up one of the Raspberry Pi's USB
USBs.
ports.
Okay.
Just go right into UNO's.
Yeah, I thought about that. You can run the Arduino IDE on the Pi
Yeah.
and program it.
Mhm.
But I didn't think about using that same cable, once things are programmed, to do serial communication.
Yeah, it works fine,
You should be able
especially
to-
since you can run the IDE on a Raspberry Pi.
Yeah,
And that sort of has all the level shifting, I guess, sort of.
Yeah, that does all the level shifting.
yeah. Good suggestion. Yes, me.
Another approach that dates back to the dawn of time is called in-band flow control, where if you're on both ends, you can put a little protocol layer in that says, when I get a magic character, stop sending.
Right.
Hmm.
So
And
you
then
are.
when I get another magic character, resume.
Yep. So
You mean like X on X off that?
That's the
It's on X off.
Yeah.
You have
That's
to
a
be able
serial.
to escape it too.
It's a serial
Transparent data.
So most UARTs have ready to send and clear to send, and so they have some, instead of just having 2 wires, 3 wires between them, if you had 2 more, 4 or 5 wires, then you can do hardware flow control, and they can communicate with each other and not overflow their buffers. There's a software layer on that if I send a certain character, an Exxon character, it's one of the low numbers, 18 or 19 or something, it's before the printable one. That means stop sending, and Exxon means, okay, you can send some more.
So why do I want to do this? What am I getting with the Uno that I can't do with the Pi?
The big thing for me is analog pins, analog input pins. So if I want to measure the pressure, the barometric pressure with my barometer chip, okay, the Pi, I've seen some hacks for doing analog
But
pins.
there's a nice little A to D chip that I can get. I've got it on my AirPi running right now at the museum.
Okay.
Why didn't I do that?
But he can reach on his shelf and pick up an Arduino and set it down and have that, right?
Except, and
And anything that can be on
I
a
can-
shield of an Arduino.
Yeah, I can buy a
okay.
motor shield from Pololu for my robot. And so it's gonna do the control of the motor for my robot, but I want the Pi to do the path planning. It's gonna do, we'll have a camera or something, it'll look for the waypoints or something, and then tell the Arduino how to run the motors to get there. So that's one example.
The Pi can't do the precise pulsing, timing, like control steppers, you know.
Right. The Pi is running Linux, which is not a real-time operating system. On the Linux, on the Pi 2, you've got 4 cores, and you can hack into the scheduler and give a particular core, this big time slice. But you can still only get like 85% of the time guaranteed.
The thing you can do with an Arduino that you can't do with the Pi is very precise timing, either measuring very precise timing or generating very precise timing. It just can't be done on the Pi. If you wanted to dim an AC light bulb and synchronize that to the AC line and generate the pulses to turn it on and dim it smoothly and brightly, you just can't do it with the Pi.
All right. There's the sketch. I need to start up the serial. And plug in the Pi. So this should look pretty similar. You'll notice some little garbage characters there. Okay. I turned the console SKU off, but even so, there's some other parts of the kernel that send out some stuff. I think it's in the bootloader. And so even though you've turned it off, you still get some. So if you're going to write a sketch on your Arduino, you better be prepared for some garbage communications that could be interpreted as just about anything, because it's sending out at 115/200 baud, and you're interpreting it at 9600 baud. And the phasing of those, you get just about any character. So now I still have the login prompt. So we're going to try to log in again. And it's not going to work. And I don't know why. Every 4th character gets dropped.
So your password, the B is dropping?
Yep.
Or the P,
So
I mean.
RAS ignored PBER ignored RY.
Wow. How'd you figure that
Oh,
out?
Yeah, how'd you-
how did I figure that? I have a logic analyzer.
Yep.
X. Oh, R-A-S.
No, you got RPi for your login, so that's not gonna take either.
No, that's okay.
Yes. That's right.
I don't know why. I think it's a bug.
Put X's on every fourth character?
I mean, I don't know. I don't know.
I mean, I noticed you use a higher baud rate in one direction versus the other.
So,
I mean, I'm sure that doesn't matter because one goes.
okay, now that, so there are two serial ports here. Okay, one is between the Uno and the host. That one I'm running at 38400. The serial port between the software serial port from the Uno to the Raspberry Pi, I'm running 9600. So I don't know why. I don't know why. You know, every fourth one, it's most likely a bug in software serial or something. It's probably not. I don't know what it is.
What if you interleaved your loops? Different,
I tried changing from whiles to ifs.
I mean, so that each loop checked both instead of draining. Right now you're draining.
Right. So if you change the while to if,
Yes.
then I do one character, go back, one character. I tried that. It didn't make any difference. All right. What do I want to do? CD space garbage character.
How long have you worked like that?
Not all that. Dot slash T.
It's weird, it resets at each line.
So Shane, so if I had an analog pressure device, I already have a way to write a Python code, I've already got it written, I've already got an A to D chip,
Yeah, that's what you
okay? If I have no idea how to write C++, in a sketch.
Probably easier to add an A to B and read it in Python.
Okay.
The only time you have to go to this is if you need to either measure very precise timing or generate very precise timing.
Okay. And what's precise?
Microseconds.
I have a
Actually, it's worse than
DHT-12 outside for temperature
Raspberry
humidity.
Pi is much worse than my.
And
Say that again. Raspberry Pi timing, real-time response figure 50 milliseconds. First. 10 milliseconds. Downhill with a tailwind. Because process scheduling, I mean, you can get interrupted at any time. You can be undercut at any time.
What if you write a device driver and you're only time critical for short bursts of data?
If you can write your own Linux device driver, then basically
It could be real time for short bursts of data, device driver communication. You could write a device.
and there are real-time priorities.
I'm not-
Right.
But not very, 50 times more extreme.
Sure.
Doing high-speed communications with some chips.
So this is my
Large driver.
backup for if the demo didn't work. There's some garbage at the front that I'm pretty sure comes from the bootloader at the high baud rate. I did an LS, and you see these strange escape sequence things. That's for color coding on VT100 terminals. If you don't want that, there's a way that you can change the VT100 to something else in the init tab, and you won't get those. All right, so for demo C, we're going to turn off the TTY, and we're going to run a Python program.
This is what I should do.
So I'm VNCing in so that I can type. So here's all it is. I'm just overwriting the init tab file and the command-line.txt file with different versions. So I'm just playing with those. Oh, I can go back. Okay, so here's the Python program we'll be running. It opens /dev/tty AMA0, which is the serial port, 9600 baud, no timeout. It's going to write a little string to it, and then it's going to take a value and write that value, increment it, modulo 256. Sleep 1/10 of a second, and repeat. So it's going to write 0, 1, 2, 3, 4, 5, 6, 7, all the way up to 255, and then it's going to go back. And we're going to see if we get that on the Pi, on the Arduino. We're running the same sketch on the Arduino, which was just copied bytes from one direction to the other. Go to the so as super user run Python demo C.py. Not much happening there. Serial monitor up. So here's demo C.py, the data code. And then it's writing out the numbers from 0 to 255. From 0 to 31 are non-printable characters. And then we get into the normal ASCII character set, blank, exclamation point. Get about to the end here, it's a delete, and then the rest of the ones are the strange characters with all the umlauts and accent graves and all that kind of stuff.
Is that at 64K baud?
No, this is, this is one character every 1/10 of a second, so it's 10 characters per second.
Okay.
Okay, because I have a delay. I can run faster.
With no delay, it would be what, like 1,000 characters a second? 960? 8 in